Hello and welcome back to Ganesh Institute. So in this video, we are going to talk about even and odd permutation, and we will dig deeper about symmetric groups when they turn into alternating groups. Okay, so let's get started. What do we mean by even and odd permutation? I'm hoping that you have got it very clearly that what do we mean by permutation. If not, then please go through the last video again. Now let's say I'm having this permutation 1, 2, 3, 4, 5, 6. There is a set having 6 elements and the permutation goes like this. Okay. All right. Now, can I ask you if the set is 1, 2, 3, 4, 5, 6, can you break it into product of permutations? Okay. Can I write it as 2 cyclic permutations? See, I have broken this down into, if you see, 1 is connected with 2, 2 with 4, and 4 with 1. So this cycle is from 1 to 4, again back to 1. So 1 till 2, 2 till 4, and 4 till 1. So this is one cyclic permutation. Yes. And then we will see that another one is 3 is connected with 5 and 5 with 3. This is another one, 3 with 5, 5 with 3. And 6 is connected with 6 because we know that the set is having 1, 2, 3, 4, 5, 6 elements. So we know that this is on its own, right? Okay, I have broken this down into 2 cyclic permutation. The length of one is 3 and another one is of length 2, correct? Now, can I break it further into transpositions only? You know, I explained this to you that transposition means a cyclic permutation but with length 2, just like this. This is a transposition, but this is not. Can I break it into the product of 2 permutations of transpositions? Let's try. So I am writing it as 1, 2, then 1, 4, and this is as it is. See, you must be wondering that this means 1 is connected with 2 and 2 is 1. But this is not the case here. 2 is by 4. But if you solve these two, tell me, what does it mean? It means it is like a product of permutation. 1 is connected by 2, right? Can I write it this way? 1, here from this permutation, 1 is connected by 2 and 2 with 1, right? And if I have to write all other elements, 3 with 3, 4 with 4, 5 with 5, correct? And 6 with 6. Okay, let me do it 6 with 6 as well. And what about this one? 1 with 4, 4 with 1, right? This is about the cycle. And rest all will be all together. 3, 4, 5, 6, correct? Now tell me what's the product will look like. You will see, I'm writing firstly 1, 2, 3, 4, 5, 6. So 6 is definitely going to connect with 6 only because that was the initial permutation. Now let's find out other one. 1 is connected by 2. Okay, but here 2 is connected by 2. 2 is connected by 1, but here 1 is connected by 4. 3 is connected by 3 only, 4 is connected by 4, and 5 with 5, correct? So ultimately, can I write it as, these are same, can I write it as 1, 2, 4? Because see, 1 is connected by 2, 2 is connected by 4, and 4 by 1. 4 by 1 is not here. Just bear with me. Yeah, and 4 by 1. So 1, 2, 4 can be expressed as this one. Yes or no? Correct? 4 by 1 was here. I I need to write it as 4 by 1. So you can see, let me tell you again. So here for this one 4 by 4, but for this one 4 by 1, right? Okay. So this is how you can break it into many transpositions. Transpositions means cycle of order 2. Okay. Now, come back to the point, which is even and odd permutations. What do we mean by even permutations? When we can express any permutation, this is a permutation, if we can express it as the product of transpositions. Transpositions means the permutation of length, cyclic permutation of length 2. If we can transform it into permutations of length 2, that is transpositions. Now count them. These are how many? 1, 2, 3. 3 is an odd number, so it is an odd permutation. If we could have broken this into 2 permutations, 2 transpositions, then that would have been called as even. So let me tell you again. You have a permutation, okay? You have found out that, oh, this is a cyclic permutation because it is connected in this manner. 1 is connected by 2, 2 is connected by 3, 3 is connected by 1. Okay? If I have considered only 3 elements from the set. Okay? So we know that permutation is a 1-1 mapping on itself. Cyclic means when every other element, I mean the end position and last position is same, and every other element is giving rest of the elements and it is forming a cycle. Now if I break it into even transpositions, transpositions means the cycle of length 2. Okay. For example, 1 is with 2, 2 is with 1. 1 is with 2, 1 is with 3, 3 is with 1. Okay. If I can break it into only 2, then that is even. If I can break it into odd transpositions, then that is an odd permutation. Okay, got it? Now let's come to the alternating groups. In our last video, we talked about symmetric group. This is alternating. That is half of the number of symmetric groups. Why? Because alternating group means you have to have the set of even permutations. Okay? But symmetric group will be having all of those permutations. So it will be having equal and even number and odd number of permutations are equal. So that's why n factorial by 2. Got it? If somebody asks you how many elements are there in an alternating group, then you have to say half of the symmetric group, or you can simply say n factorial by 2. Alright? This is it for today. Keep learning and don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye-bye.